Hello and welcome to CEN 4801. In the last session, we addressed the definition of a system. We also talked about the different types of systems, and we addressed the analysis methods, the different methods, and the most important thing, or one of them, was thinking, system thinking, how to approach any system with holistic thinking. And then we talked about systems engineering. In this session, we are going to address the system attributes, properties, and characteristics. In some cases, or some organization, they say that maybe all of these are the same attributes, the same as properties, the same as characteristics. But in other cases, each one of them address specific uh, type of system related maybe uh, area or different, let's say, the attributes and properties and characteristics. So each one of them is something different, and we will see how would that work, or what are the examples of that. Why do we need to do that? Why do we need to understand the system attributes, properties, and characteristics? We need that because if we can identify the system attributes, the proper system attributes that need to be developed, then during the development, the design and development of a system, we will understand each step, each process of the system, how the system interacts with each other, the different components interact with each other, and what will be the most efficient way to make these components interact, providing the or achieving the main goal of the system. So by identifying that, we will understand how to characterize a system in terms of its attributes, properties, and performance. We can change the attributes based on user or customer requirements, or basically customize those attributes to fit certain organization. And that's why we analyzed the system to begin with. We were looking at the different types of system we analyzed, and we addressed some of the analysis methods, or the methods that will be used for analyzing the system. So let's see the difference. Uh, Again, it might be a slight difference between the attributes, properties, and characteristics, but we have to look at each one of them differently in certain situations. So for the attributes, it is classified as functional or physical features of a system. Those attributes are common across natural and man-made systems. The attributes will be used as a checklist for system specifications by system developers. Whatever the attributes that's been identified during the analysis, those are the checklist. When you are building or designing or developing a system, then you will be going through this checklist, making sure that you did include each one of these attributes within the design of that system. Not only that, but also when you are testing the system to make sure that it's adequate and it's according to specifications, systems engineers, they use this checklist to make sure that it's according to the customer requirements or according to specifications. So the assessment will help identifying any holes or gaps in the specification requirements, and by doing that you go back, change the design, adjust, and make sure that the system is being developed or being built according to specifications. Examples of attributes, we will talk about maintainability, reliability, productivity, effectiveness, and efficiency of a system. Those are just examples, but there are many like that. But usually, if you are building a system, you would like to know how frequently will be maintained. You would like to know what kind of maintenance you need to perform, maybe the steps or the procedure that's needed to be done through that maintainability procedure. Also, you need to know about the reliability of the system, how reliable, what kind of um, uh, redundancy do I need in the system, so I will make it reliable. And reliable means, it's working when I need it. So if in case I have only one line of production, if it shuts down, then the whole company is down. There has to be like another production line or something that will at least make me recover from that downtime. Also, for productivity, I would like to know how much output would I get from certain input. Usually, the productivity is the output divided by the input, and this is how I know that I'm productive or not. And of course, that for effectiveness and efficiency, you would like your production line or your system to achieve the goal through effective process and through efficient process, whether time wise, budget wise, or any other related factors. You would like it to be efficient and be the uh, maybe cheapest or more profitable, um, will be also within time when customer needs that. The common attributes of management information system, for example, if we took as uh, IT specialist or specialized in information technology, and usually we deal with networks, information systems, software development, and software packages. Um, we would like to know some of the attributes. What are some of the attributes, for example, the management information system? Some of the attributes are, that it's fixed and standard format report. It has that built in within it, and reports consisting of hard copies and soft copies, either electronic that can be sent distributed via email, or it can be hard copy that will be printed and distributed through the paperwork or the hard copies. The information system has usage of internal data that's saved in the system. It will allow the end users to develop or modify custom reports as needed, and it allow users to send a request to generate that report or to distribute that report in a certain way. How about properties? The system properties refer to the mass properties of a system. For example, we are talking about the weight, the density, the length, the width, the height. Those are considered as properties for a system. Um, in most cases, when we are dealing with like information system, or we are dealing with software packages, the development of a software or database or networking, sometimes these things doesn't make a difference. But in some cases, when we are dealing with hardware within a system, then I need to measure the weight of the different hardware that I'm using. For example, if I have laptops, it's very important for me to have the laptop lightweight, so the employee or whoever gonna carry the laptop will not be affected with a heavy weight. So weight is an issue. Also, the size is an issue. With the length and width and height of that laptop, uh, it uh, it will be hard to fit maybe in a bag or something. Then that will be an issue. So all these could be properties of a hardware that will be used in an information technology or in a system. The server size, the workstation, where do we fit that workstation, on the desk or under the desk? All these, when you come to build a network system or a network or configure a network within the organization, then you have to look at these type of properties for some of the hardware that you will be using. For systems characteristics, it refers to the behavioral and physical qualities that uniquely identify each system. The behavioral characteristics include predictability and responsiveness of that system. Can we predict what will happen if we do this type of change or this kind of scenario? That's what we need to know. We need a system that can be predicted so we can adjust as needed. We need a system that will respond in time when I need to respond. So I'm looking at predictability and responsiveness. There are some of the physical characteristics that includes equipment warm-up, stabilization profiles, for example, the aircraft radar cross sections, the vehicle acceleration to cruise speed. Those are physical characteristics of a system. To understand that from our point, which is information system and information technology, what are the characteristics or common characteristics of a management information system? In this slide, you can see an example of that, and we can see that first of all, we need a system that is understandable. So information must be understood by the receiver so that he or she will interpret it correctly. It should be relevant, so information should be pertinent and meaningful to the decision makers and their area of responsibility. The information that's inside that system or within that system, the database that's being built, has to be understandable and relevant. Also, it has to be complete. In most cases, when you are collecting data, you will see lots of missing points, missing data that will make it very hard for the decision maker to take the proper decision when analyzing it. It's not complete. So we need to make sure that the information is complete, and this is one of the main characteristics of an information system. And we have to make sure of availability, that information should be available when needed, and I should have accessibility to it. So those are the common characteristics of a management information system. Also, we need a system that is reliable, that is trustworthy, accurate, consistent, and verifiable. We need concise information, which is, information that is just for my study or my research area. If you saturate the system with lots of information that might not be related, then the analysis will take more time. At the end, I have to filter those information, so that will take me more time just to understand and to get the information that I need. So it's better to be concise, where it's just related or enough to the decision maker to make that decision. It should be timely, which is information must be delivered at the right time and the right place to the right person. And it should be cost effective. So information is not desirable if the solution is more costly than the problem. If I'm collecting the information, analyzing it, and that will cost me way more than the solution itself, then that's not gonna work. So those are the 8 common characteristics of a management information system. So if we look at systems attributes, properties, and characteristics, we can say that they are the sum of systems attributes, properties, and characteristics that uniquely identifies and distinguish a system from other systems of the same classification. Every man-made or natural system have their own attributes that uniquely characterize those systems. And if you look at what I said here, you can see that uniquely characterize, which means, at the end, we can consider that those attributes and properties and characteristics all characterize its characteristics, basically characteristics. But, we would like always to separate them for the sake of understanding that system and how it works. So what are some of the attributes that should be considered when building a software, for example? And again, we are trying to relate the system attributes, properties, and characteristics to our field of study, which is information technology, and how would that work in our case. And of course, when you are building a software, you would like it to be debuggable. I don't know if this is a word or not, but you would like something to be debuggable, where you can debug and easy get to the error and fix it. You want it to be extensible, which has the ability to extend to the level of effort required to implement any extension or any changes later on. Portability, the ability of the software to be ported from one system to another. Usually we have to change, for example, the operating system. So you'd like for that software to change from the Windows 7 environment to the Windows 10 environment without any problem, and that's portability, being able to move it from one place to another without any problem. Scalability is the ability to handle the growing amount of work and use for that software. If I have hundreds of employees now, but in about 5 years I will have thousands of employees, then I need to make sure that the software is scalable enough to handle all the amount of work and use that will be from the employees and the change of number for the employees. With all these number of employees, with all the open access or accessibility or level of access, then I need to secure the information within that system. I need to secure the software, and to secure the software I need to have some kind of maybe either a feature that I will add to the software, or I will add another software to protect that software. Usually now most of the software developer, they are building a security feature within that software, so you will not be able to get access to the things unless you have certain level of authorization. So they will build the authorization and the access level within that software. Testability, once you develop that software, you want to test it, you want to make sure that it's working fine, so you need an easy test platform where you can test it and make the proper changes as needed. And of course, understandability, easy to understand, and usability, easy to use. And those two things, you want the least amount of training to get the employees up to date and get them to use that system without any problems. That's why you would like to make it understandable, the steps, the procedures that you do through the software when you navigate or maneuver through that package. It needs to be easy so they can understand it and use it easily. How about the database attributes? For database, we're looking for reliability, availability, scalability, and recoverability. And we need to understand the meaning of each one of them. So explore those attributes and know exactly what they mean, especially the last one, recoverability. What do I need to do to be able to recover the database? This is one of the most important attributes in a database. So look at these features and see how you can implement that on a database and write them down, explore them, research them, and write them down to understand how it works. If I don't know the system, or a system is new, it's not an existing system. It was not there before. How would I build one? Usually, we have in these cases we have to involve a user. So the user will be interviewed or surveyed. I will talk about these methods in a minute, but we need to collect the information from the user, and those information will include the system requirements, and that's why we call them user requirements specification or requirement specifications, which is a document that's usually used in software engineering that specifies what the user expects the software to be able to do. User requirements will be translated into software specifications later on. We have tools, different tools to do that, and to map user requirements to software specifications. The user requirements for a system specifies what the user expects that system to be able to do. And in the same manner, user requirements will be translated into system requirements later on. So whether we are talking about a software or we are talking about a system, we are saying that it's the same. Now remember that a software is considered as a system. So the system user requirements is generally a planning document that's created when a business is planning on acquiring a system and is trying to determine specific needs. The user requirements will analyze to design and develop a system, will be analyzed to design and develop a system that meets the expectations of users and customers, which is critical to the success of the organization. And of course, user requirements analysis provides precise description of the content, functionality, and quality demanded by prospective users. User requirements analysis provides attributes, properties, and characteristics of the system. Exactly, this is what we are asking them to do. What do you want to have in this system? What kind of attributes, what kind of properties, what kind of characteristics, and what do you need that software to do or that system to do, and based on that we translate that into system specifications. The requirements could be either functional requirements or non-functional requirements. For the functional requirements, those are the tasks that are intended to be performed by the system or its components. The plan for implementing functional requirements is detailed in the system design. For functional requirements, maybe calculations or technical details or data manipulation and processing and other specific functionality that define what a system is supposed to accomplish, and this is what's related to the functional. While with the non-functional requirements, those are requirements that specifies criteria that can be used to judge the operation of a system rather than specific behaviors. We can define the non-functional requirements as the plan for implementing non-functional requirements, which is detailed in system architecture. So the functional are in the system design, while the non-functional in the system architecture, because they are usually architecturally significant requirements. For example, in a network system, the network topology is a non-functional requirement. Excuse me. So the requirements, if we look at the functional and non-functional, um, we can see that the functional requirements are supported by the non-functional requirements, and the functional requirements are expressed in the form of system must do, while the non-functional requirements are system shall be. The functional requirements drive the application architecture of a system, while non-functional requirements drive the technical architecture of a system. The different methods for user requirements analysis, and this is what I was talking about, is if it's an existing system, then we can observe and document what the user needs. We can interview the users and collect the requirements. We can make focus groups and ask them exactly what do they need, and then document that. We can do checklists. We can do questionnaires or surveys. We can do use case studies. We can look at other competitors and analyze what they have in their system, and then either copy or make better functionalities or attributes, properties, and characteristics. And in this table, you can see that the different tools, how they are employed. So we can see the method, the description of that method, the benefit of having that method, and the drawbacks of that method. Usually, most of the organization, they use 2 or 3 types to cover the drawbacks, the disadvantages of each one of them. So if there is a disadvantage in certain method, I can take another method or use another method to cover the drawbacks or the disadvantages from the other one. What's the effectiveness of this analysis? Would this analysis be good actually, and give me a good system at the end? Actually, collecting user requirements for consumer products requires much efforts, and the risk of failing will be very high. As long as consumers have no idea of the innovative product or service, it will be very difficult for them to state their needs. If it's a new product, if it's not in the market, and you are trying to add a new product in the market, they will not know um, what kind of product you are talking about. Usually what they do in these cases, they will have some kind of prototype that they will show it to the consumer and ask them, would you buy that? Can you use it? And in most cases, that prototype has to be functional to convince that consumer that they can use it or they can buy it or easy to use. And if that prototype was not functional, then you cannot collect the information properly. So it's for the creativity of the designers to transfer the user requirements into innovative consumer products. They have to understand consumer behavior, the need of that consumer, so they can translate that into a product. For the development of professional applications, precise user requirements analysis and specifications is essential. It's very important. User requirements analysis is an error-prone part of the development process, and errors not detected at this stage may lead to expensive system failures. It's very important to collect the proper information, very important to understand the system from the beginning so you can develop it the right way. Otherwise, it will be failure, and it will be a very expensive failure that will cost the company a lot. That's why they do it right, and they do it one time. So they spend a lot of time on understanding the requirements, translating that into specifications, and that will what will make it a successful product or application. With this, we end up with the last slide of the second session. That will be all for this one. If you have any questions, please use the communication channels to send it to me, and I will be more than glad to answer your questions. Have a great day.